A pendulum can be described as a weight that's suspended from a pivot point. So if here's our pivot point, and we have a mass that's suspended from that point, and it can swing freely back and forth, then we would consider this a pendulum. When it's displaced sideways from the equilibrium position, so in this case our equilibrium position would be straight down. So when it's displaced to either side, it's subject to what's called a restoring force, or in this case it would be gravity that will accelerate it back towards this position here, this equilibrium position. So as we bring the mass up, acceleration pulls it back. And this restoring force is what causes it to oscillate back and forth, or swing back and forth from the equilibrium position. And the time that it takes to complete one cycle, so that means up, the other way, and back, is the period. And for these types of pendulums, we assume that this point here is frictionless and that this string or rod here is massless. The only mass we consider is of the object itself, and we consider its change from the equilibrium position by any distance that it travels here along this arc, which is described by the angle, that should be a theta, that it is moved from the equilibrium point here. If we were to consider this arc, we need to know this angle as well. Our equation for the period of this type of pendulum is T equals 2 pi times the square root of L over G. And L in this case is this distance here. G is 9.8 meters per second squared, the acceleration due to gravity on Earth. If we were to change planets, it would be whatever the gravity of that planet is, and L is the length. Oops. Today we use pendulums for things like grandfather clocks. They're used in scientific instruments such as accelerometers, which measure acceleration, or seismometers, which measure, in our case, any kind of seismic activity. And they were used in the past to measure the acceleration due to gravity, but now we know that it's this constant, so we actually don't use them for that purpose anymore.